Hi friends, this is Parvati from KAPS Exam. Welcome to my channel. I need your support, so please subscribe, share and like my channel. Also, you can mention your valuable comments in the comment box. Today we are discussing from the pharmaceutical next portion, pharmaceutical solvents. I think powder already we finished it, solid dosage form also tablet also we finished it. Then the third one is solvent. Solvent mainly I take the reference from CPR. Okay, page number I already mentioned in the first slide, page number 35. You can check it there also. Okay. Everybody know the water is the most commonly used vehicle for drug solutions. So many different types are coming under water, mainly 7 types of water for preparation of dosage forms, but only 3 I am discussing here. Remaining one, if you want, you can check in the detailed description in CPR, but these are the main important ones, so that's why I mentioned this one only here. Purified water, water for injection, sterile water for injection. Out of 3, water for injection is most important one. The purpose of water for injection mainly used for preparation of parenteral solutions. Very important point. We can expect question from this portion. Okay. The next one we are discussing here, alcohol. Alcohol, the types of and examples of alcohol mainly discussing here: ethanol, hydroalcohol, rubbing alcohol, glycerin or glycerol. And hydroalcohol form, everybody know, hydroxyl group and alcohol group. Combine with this one, hydroalcohol, the diluted form of alcohol also. Ethanol also diluted form of alcohol. Okay, hydroalcohol mainly used for the purpose of sanitizers and disinfectants. More than 60% is good for killing bacteria, so that's why it's used as sanitizers. Okay, 2 examples I mentioned here: isopropyl alcohol. Methanol or methyl alcohol is the more toxic form. Okay. Then the glycerin, everybody know the purpose, mainly it's used for the moisturizing purpose. Okay, and rubbing alcohol also mentioned here. Okay, these are the common alcohol types and examples. The next slide I mentioned the co-solvent. Co-solvent, different examples I mentioned here: ethanol, propylene glycol, glycerin. These are mainly used for co-solvent. Substance added to a primary solvent to increase the solubility. That is the purpose of solvent. If a poorly soluble compound, we want to increase the solubility, so that purpose we are using the co-solvent. Then the next one we are discussing here, advantages and disadvantages. Water, alcohol, co-solvent. What are the advantages? Water is mainly, everybody know, most common one, and low toxicity and low cost also. Disadvantages: it does not dissolve many drug compounds. That is the important disadvantage of water. Not important, common disadvantage of water. Okay, alcohol means drug not sufficiently soluble in water and can serve as preserve at high concentrations. These are the main advantages. The disadvantage is toxic used at high concentration. If we are using at high concentrations, it becomes toxic. Okay. Then co-solvent, mainly advantages are drug is not sufficiently soluble in water. So the disadvantage is toxic if used at high concentration, same as alcohol. Okay. The next slide we are discussing the solutions. Solutions means, everybody know, solute plus solvent. That preparation is called solutions. 2 types are mainly coming: aqueous solutions and non-aqueous solutions. These are important slides. Okay. Mainly the syrups, elixirs, whatever we are discussing here, these are important topics. We can expect question from this one and the next slide I mentioned also. You can check it thoroughly. We want to study this portion. Okay. So the first one is syrup. Syrup means simply flavored. Everybody know that one. Sugar or sugar substitute as base of flavoring agent we are using. Okay. Then concentrated aqueous preparation is known as syrup. The mainly route of administration is oral. Okay. Elixirs, it's clear and less sweeter and viscous also compare with syrup. Okay. Then free flowing types is normally the elixirs. It's a hydroalcoholic form. Normally it's contain 5 to 40%. These points based questions we can expect, so you want to thorough with each and every one. Okay. And normally the route of administration is oral, elixirs. Okay. The next one we are discussing here, tinctures. Tinctures means alcoholic or hydroalcoholic solution. Mainly the percentage is coming 15 to 80% alcoholic percentage is coming for tinctures. Okay. Then it's a chemical substance formula. Route of administration is oral. Okay. Then collodions. Collodion says Pyroxylin dissolved in alcohol and ether. This formulations is called collodions. Normally it's used for the topical purpose, mainly used for wound, like that category. So route of administration is topical. Collodion is used for topical purpose. Spirit, alcoholic or hydroalcoholic solution of volatile substances. The alcohol content contains 60%. Route of administration spirit orally, and it's also applied externally or used as inhalation also. Okay. Liniments is alcoholic or oleaginous solutions for rubbing on skin. That means it's rubeficient or counter-irritant or penetrating action also. This form have the penetrating action also. Route of administration is topical. Very simple point, but these are important also. We can expect question from this portion. I had it also in my exam also. Okay, but we don't know which one they are asking. Everything is important. Okay. Then the next slide we are discussing whatever the benefit and examples of types of this formulation: syrup, elixir, tincture, collodion, spirit, liniments. You can just read it. Maybe not that much important, but we want to know it. Some of the points maybe we can expect. Okay. So that's why I mentioned here. Just read it and go through these slides also. Okay. Then the next topic we are discussing here, the first solution formula, liquid solution. Liquid solution we are discussing here. The mainly the Raoult's law is coming under based on this solution, liquid. Okay. Raoult's law states that the partial vapor pressure of each component in an ideal mixture of liquid is equal to the vapor pressure of the pure component multiplied by its mole fraction in the mixture. What is the equation and what is representing each part I already mentioned here. If you want more about this one, you can check in the page number of CPR 24. But this much is enough only. We want to just know about the equation and what is the purpose and whatever the components are coming. That's only we want to know it. So that much only I mentioned here also. Okay. Then the next slide I mentioned here, Raoult's law mainly the ideal solution and non-ideal solution. It's based on this. Ideal solution is it's obey the Raoult's law. Non-ideal solution means that is not obey the Raoult's law. In the non-ideal solution, the other portion it's coming positive deviation and negative deviation. That graph also I mentioned. That means its deviation from the Raoult's law is showing by positive deviation and negative deviation. You can just check it these slides. Mainly the equation is most important one. Maybe we can expect from the question also the ideal solution and non-ideal solution. Then the next slide we are discussing here, pairs of liquid. Pairs of liquid everybody know, immiscible, miscible and partially miscible. Immiscible means that is not mixing together. That common example is oil and water. One more example also I mentioned here, mercury and water. Miscible means that is solubility of two liquids. Example, ethanol and water, that is fully mixed. Solubility is fully soluble in the water is fully soluble in the ethanol. The partially miscible means phenol and water, not fully soluble in the water, but 70% or 60%, some of the percentage it's soluble in the water is called partially miscible. Okay. Then miscible versus immiscible, just representation I mentioned here for the understanding I mentioned here. You can just check it. Same as that one. Okay. Then the next slide we are discussing here, solid liquid solution. Solid liquid means solid part is there and the solvent part is there. So sugar plus water, normal common example for the solid liquid solution. Mainly in this portion, colligative properties very important in this pharmaceutics portion. We can expect questions based on that, but we didn't discussing here detailed description about the colligative properties, because we will study in the detailed study in homogeneous and heterogeneous systems. So that's why I didn't mention here. But whatever the colligative properties, 4 colligative properties, whatever that one I mentioned here, but we will study in the preparation portion. That time we will discussing about more. Not only this one, we will discuss about the electrolytes, non-electrolytes, isotonic, hypertonic. These are mainly discussing detailing on that topic also. So that's why I didn't mention here, but it's very important. Okay. Colligative properties means property of a solution depend on the ratio between the total number of solute particles in the solution to the total number of solvent particles. Four types are mainly coming: lowering of vapor pressure, elevation of boiling point, depression of freezing point, and osmotic pressure. Then the next slide I mentioned here, isotonic solution. What is the isotonic solution? Everybody know the concentration is equal to the blood. That is called isotonic solution. A solution that has the same salt concentration as the normal cells of the body and the blood. Main examples everybody know. The common example is 0.9% sodium chloride. The other examples are mainly it's used as intravenous fluid. So ringer lactate, blood component, dextrose. These are main examples for the isotonic solution. This is mainly used for the infusion purpose. Okay. Then the next slide is very very important. Isotonic, hypotonic, hypertonic. Isotonic means solution is one that has the same osmotic pressure as body fluids is called isotonic. Hypotonic means it's lower the osmotic pressure than body fluids. Hypertonic means solution has an osmotic pressure that greater than the body fluids. These are the three types of very important. Okay, we can expect questions based on this one. So you can thorough with that one. Okay, the next slide we are discussing here. And then the types of solutes, electrolytes and non-electrolytes. These are the two types coming. The main difference is electrolyte substance that when dissolved in water, it conducts the electricity. Common example is sodium chloride, and has ions in the solution also it's forming. So the dissociation, that process is called dissociation. Okay. Then non-electrolyte means substance that when dissolved in water does not conduct electricity. These are called non-electrolytes. Main common example is the sucrose or sugar, that means glucose. Okay. Then does not have ions in solution but molecules. Okay. Then the next slide is mentioned, and this topic also we will detail study about in our next topic, in the coming topic, homogeneous and heterogeneous system. Okay. The next slide I mentioned here. Ions means the ions produced as a result of ionization of weak electrolytes are present in a dynamic equilibrium. This equilibrium is called ionic equilibrium. That means the dynamic equilibrium with the unionized molecules. This equilibrium is called ionic equilibrium. Okay. What is buffer solution is the next point. Buffer solution is a special type of solution that resists change in its pH. When small amount of an acid or base are added, it resists the changes in pH. The solution is called buffer solution. It consists of weak acid and its conjugate base, or the solution contains a weak base and its conjugate acid. The next type is gas liquid solution. Gas liquid solution is mainly describing here the Henry's law. Okay. Henry's law is used to quantify the solubility of a gases in liquids as a function of the gas's partial pressure. These are the Henry's law. What is the definition? The equation is discussing here in the next slide. At a constant temperature, the amount of gases dissolved in a liquid is directly proportional to the partial pressure of the gas in equilibrium with the liquid. This is mainly known as the Henry's law. Okay. The partial pressure is directly proportional to the concentration. That means if the pressure is increases, the concentration also increases. The equation, the one more is I mentioned here. That one mainly the dissociation constant also. The Henry's law constant also we add it. Then we replace the equation with like this one. Okay, what are the components are coming I described here, you can just check it. The equations we want to know it mainly what is happening, what is the directly proportional, inversely proportional. We can expect the questions based on this, or otherwise the solutions based, what is the Henry's law based on this one, that like that also we can expect. So that's why I mentioned here. Okay, and one of the example, the common normal example is opening a soda bottle, that is the gas liquid solutions common example. Okay, then the Henry's law is generally applicable to solutions with low solute concentrations, that is typically up to a 5% by mole fraction. That is the another point, important point for the Henry's law. Okay, the next slide we are discussing here, whatever the factors affecting the solubility, very very important, each factors is very important. Okay, we want to thorough with this points, this table. Okay, I think 3 slides are coming based on that. 3 slides very important, you should thorough with this one. Okay, the first one is pH. PH is inversely proportional, that means if pH is increases, solubility is decreases. If for the basic solutions becomes, that means it's the pH is increases means that solution becomes more basic. Basic means the solubility inversely proportional, so the solubility will decrease. If the pH is decreased means the solution becomes more acidic, that solution is acidic solutions. Okay, the solubility, if the pH is decreases means the solubility will increases. Okay, then the next one is pK. pK means dissociation constant for calculating the solubility at certain pH values. Okay, then the next slide is coming for the salts. Salts, addition of a salt that increases or either decreases the solubility. So if the solubility is decreases by common ion effect, that means common ion effect is the add excess ion. When a solvent shares a common ion with the salt, that solubility will decreases. Okay, that means the common ion effect is happen, the excess add the excess ion means the solubility will decrease. That is the main point. Okay, example also I mentioned here. If a solution, that means a sodium acetate solution that contains already the sodium ions, if we add more the sodium chloride, what will happen? The solubility of the sodium chloride will be decreased because it shares the sodium ions with the solution. So that is the reason the solubility of the sodium chloride will be decreases. That is the main point based on this one. Okay, and temperature, the next one, temperature is directly proportional. Temperature increases means solubility will increases. So very simple and but important also. And esterification means esterification increase the solubility. When the solubility is increases, if the esters of the chain is short, the increase the solubility. But if the longer the esters, long chain esters, that means solubility will decreases. And then the complexation, and one more important point is there, longer the esters, long side chains, that means greater interference with the solubility. Okay, then the next one is complexation. Complexation means addition of ligands increase or decrease solubility, same as the salts. Salts means increase or decrease solubility, same as like complexation also happen. Then solubilization. Solubilization mainly the micellar solubilization that increase the solubility of poorly soluble drugs. If the drug is very poorly soluble drugs is there, we can increase the solubility by the micellar solubilization. Okay, the micellar solubilization increase solubility of a poorly soluble drugs, where poorly soluble drugs are loaded into the core. That means the drug is loaded in a core of the material. The outer shell it's coming, the micelle shell, that is hydrophilic, so they solubilize the drug. Okay, that is helps to solubilize the drug. The poor soluble drug is inserted into the hydrophobic core of the micelle. That is the purpose for micellar solubilization. Okay, so the micellar solubilization, it increases the solubility. That is the main point. Okay, the next slide we are discussing here, dissolution. The first portion is dissolving particle. Dissolving particle, it's mainly the dissolution we know. If we solute is added into the solvent, it becomes solution. So the dissolving particle is surrounded by mainly 2 layers. The first one is the boundary layer, and the second one is the concentration change. One graphical representation also I mentioned here, where the crystal form which part, where the boundary layers is coming. When the solvent is it's added into the solvent, the concentration of solute will varying. Okay, then the next slide we are discussing here, the first stage. 2 stages we already mentioned, the boundary layer and the concentration chain. In the first stage, interfacial reaction. Interfacial reaction, in this reaction, molecules of the solid becomes molecules of solute in the solvent. The solid is dissolving in the solution. Okay, that is the first stage, that is interfacial reaction. The second stage reaction, the solute particles migrating from the boundary layer to the rest of the solution. It's already represented in the picture in the whatever the dissolution and dissolving particle one graph is mentioned there. So the second stage, what is that? In the second stage, what's happening? The solute particles migrating from the boundary layer to the rest of the solution. So what will happen there? We can see from this picture, the concentration of the solute is decreases. It moves into the solvent. So when we add the solute, that time the concentration is very high. Then it's migrating from the boundary layer to the rest of the solution, the concentration will decreases. Concentration of the solute will decreases. That is the main point. Okay. Based on this one, the dissolution, one of the important equation we are discussing here, Nash-Whitney equation. Nash-Whitney equation is mainly used for the dissolution rate. Okay, what is the equation and what are the components is coming? I mentioned here. You can check it. We want to thorough with the equations. Mainly, we can expect the based questions in the KAPS also. Okay, so each and every, I think near to 4 equations we already over from this topic when we started from the liquid solution. From that time the Rawls law we discussed, and Nash-Whitney now it's discussed. Then we already discussed about the Henry's law. Just thorough with the equations. Okay. Then the next topic we are discussing here, the continuation of the Nash-Whitney equation I already mentioned here. Rate of dissolution is directly, we can see from the equation also what is directly proportional, what is inversely proportional. The rate of dissolution is directly proportional to the area of migration and concentration difference also. That means delta C. The rate of dissolution is inversely proportional to the thickness of boundary layer. These are also important. Okay. And the next topic is coming diffusion. Diffusion, everybody know, the movement of drug from a region of higher concentration to the lower concentration until it reaches the equilibrium. That is called diffusion. Okay. In this portion, we are discussing the equation Fick's first law and the Fick's second law also. Fick's first law we are discussing here. Mainly, the movement of drug is directly proportional to its concentration gradient. That is called the Fick's law. What is the equation and what are the components are coming in the equation? I already mentioned here. You can thorough with that one also. So every equation is important. It's this one based calculations we don't want to study it, but these equations are important. Okay, equations means what is the purpose of equations. These are very important, so we want to thorough with that one. Okay, in the KAPS exam we don't want the calculations based on this. Okay, then the Fick's second law relates to change in concentration of drug with time. So the Fick's first law is the directly proportional to the concentration gradient. In the second law, what is that? It's related to change in concentration of drug with time. So in the steady state diffusion, the concentration gradient does not change, but in the non-steady state diffusion, the concentration gradient will be changing. Okay. Then the surface chemistry. These are just whatever the important points we want to know about it. That one only I mentioned here. So in the surface chemistry, the interfacial tension is important. One of the important point. But I didn't get any questions from this portion. But these are the important points we want to know it. So that's why I mentioned. Maybe we can expect. Okay. So that's why each and every topics is important. So that's why I mentioned this one. Okay. Interfacial tension means tension that exerts between two phases when mixed. That force is called the interfacial tension. Okay. And excess between liquid solid and solid gas phases. That interfacial tensions tells about the miscibility of two phases. Miscibility we already know, the solubility. Okay, the solute is soluble in the solution like that. Fully soluble in the solution, that is miscible. Okay, so interfacial tension tells about the miscibility of two phases. Okay, high interfacial tension means greater amount of work is need to mix the two phases. Okay. If the liquid or solid phases we want to apply it more greater amount of work, that is meant high interfacial tension. Okay. The next slide we are discussing about the surface tension. Surface tension means tension resulting from the contact of a liquid and gas phase. that is surface tension, and spreading is the process where a substance or material extends over a surface. That is, we know something we are spreading to in the other phase. That is only the spreading, normal simple definition. This can such as liquid spreading. Normal simple example is liquid spreading on a solid surface. Okay, two forces mainly coming under the spreading: adhesive force and cohesive force. Adhesive force means attraction between unlike molecules. Example, the normal common example is attraction between water molecules and the glass. Okay, the next one is cohesive force. Cohesive means like molecules, attraction between the like molecules. Example, the attraction between water molecules themselves. That is called the cohesive force. If the adhesive force is stronger than the cohesive forces, the liquid will spread. Okay, means adhesive forces are the stronger force than cohesive forces. Okay. Then the next slide we are discussing about tendency of wetting. Tendency of liquid molecules to maintain contact with a surface. That is the tendency of wetting. If the liquid molecules to maintain a contact surface of that tendency is called the tendency of wetting. And if substance does not spread and wetting, that means that is droplet. That form is called droplet. Okay, there is another one is the contact angle. Contact angle, it varies from, mainly the range is 0 degree to 180 degree. 0 degree means it's perfect wetting. Okay, the liquid spreads completely over the surface. 180 degree means no wetting. The liquid forms a perfect sphere and does not spread at all. That means 180 degree. This is the limit for the contact angle. Okay. And the partial wetting also discussing, I think, the 90 degree. But this much only we want to know it. If you want, you can check it. Okay, in the detailed description also you can check in the textbook. Okay, and liquid very weakly attracted to gas but strongly attracted to solid liquid, greater attractive forces. Okay. The liquid greater attractive forces between the liquid molecules is equal to greater contact angle. Okay, these are the contact angle based on the points we want to know it. I didn't see the questions from this portion, means I didn't get the questions from this portion, but we want to know it this point, so that's why I discussing the last two slides. More important points based on the surface tension and interfacial tensions, these are the main important one. The others points also you can just read it. Maybe if they ask, we want to attend it, don't miss even 1 mark, so that's why I mentioned. If you want the detailed description, you can check in the text or the Google. So many facilities are available, you can check it. Today I am just wind up here. These are the only portions we want to know about the solvents. Then remaining portions in the ceotics, it's coming emulsions, ointments, suppositories. These are remaining, and parenteral formulations also. Coming classes I will include, I am trying to complete in one portion. Okay, coming classes we will include the next dosage forms also. Parallelly we are continuing the autonomic nervous system. So today I am just wind up here. Okay, thank you. One more time I am reminding, please subscribe, like, and share my channel. Also you can mention your valuable comments in the comment box. Okay, thank you.